All right, should be live. My chair in order. So, welcome back. Today, I'm first going to do a thing I promised Alyssa, which is a parser. This has been on the list forever. I tweeted about this ages ago. But a parser for the data format, the serialization format that DCP uses to send information about modes and stuff to the main processor, and that shouldn't be a big deal. Because I already tweeted about that a while ago. It's a very simple JSON-like thing. A second JSON-like thing, because DCP already has one of those. But this should be pretty easy. Basically, in here, in ipc.py, I really should split the instance into multiple files, shouldn't I? But yeah, this OS object thing is a different one. So I should write a... what to even call this? IOK dict or something like that, I guess. That probably makes sense. And this does a parse string context. Yeah. So basically, it's not. It's yes, it needs to be a contract parse like this. Key it. Okay, props, I guess, or something like that. Actually, there's a name. This had something. Oh, it's yeah, it's always serialized, I guess, but let's call it always serialize. Let me get the chat in order to. There we go. Serialize construct. And there's going to be no types on that construction. I'm just going to recursively parse in here. And then basically what we're going to do is equals stream read 1 read 4. Actually, we just do an int32 UL. And then the header is going to be D3. And then basically it'll just be return self parse object stream. I don't think we need context or path for anything there. And so then, and we're not doing builds. I don't think we need build for anything here. Obviously, there's no size of, so that's all the same. Yeah. So what we do is tag stream will be an int32ul.parse stream. That gets me the tag, and then the type is in the top byte. And the length is there. And then actually, let's go size. Type is equal for flags, and I think it'll all. Let's give it an extra bit just in case. And then it should be. The last one should have a last ID, but I think we don't care about the last flag. So we can probably just ignore that. Or just do a parse and return true if it's last and a search for that. Yeah, that makes sense. So if it has that, it's last. Actually, let's just do last equals tag. Oh, I hate it when that happens. I tend to hit Control W. And this will just be old type. And then the only object types that we can see are 9, which is a string, null terminated, and that has hold on. There's a 3 at the end there. What was that about? Is that just padding? Oh, it's just aligned. Yeah, I forgot about that. It's just aligned to. It's just the number of padding bytes. Yeah. So it does like 1, 2, and 3 depending on how many extra bytes need to be added. And the length is just the length of the string. So I need to align that to 4 bytes. Is there a thing for that in? Yeah, but there's only just by length. I need a stream for this. Where is that? I think we should have to look at the source code. I might not. Yeah, let me just look at the source. User lib python 3.9 site packages construct core not stream error and stream. Oh, is it just hold on. Oh, it's just IO bytes. Okay, it's a standard bytes IO thing. So just tell and seek should do it. Yeah. So let's just do it at the beginning of parse object. Actually, you can just do something like that. For my cool. And then it's just it got reloaded. 947.6c. Cool. So if O type equals 1, it's a dictionary. Yes, it is. And it should be key value, key value. So this is basically the same as this. Then the next one we need to take care of is the array, and that one is just the number of things. So, which we didn't have before, actually, we didn't use that one. So, actually, we can just say do it like that. Array should just be that. What else do we have? We have 4s, which is int64. B is probably null. 11. Nine is a string. Just gonna be like this. And that is 6 is without any null termination or anything. There's no null termination, so that's easy. So we don't need that. We got 4, 9, 6. Anything else in use? Well, there's that IO kit stiff, so might as well look at the original source code just to get the tag types anyway. Where's the tag types? libkern. Probably in here. Yeah. 3 is a set. I don't think we use those. Oh, so we have number, symbol. Okay, so we'll use that. I don't think we have symbols. We have strings. We don't think we use data. OB is Boolean. So actually, this is. How does that work? Probably just the size or something. C subject. I don't think we use that. So how do they do Booleans? Okay, so it's just the size is the value actually for Boolean. Yeah. Cool. I think that's it then. Yeah, that should be pretty much it. And then the trick is here in manager, we have those callbacks with the prop start and yeah. Let's just refresh that. Not playing things, prop chunt. Which should be the same as length. Let's check that the API layer. And then finally, this sets the key. So we need DCP AV prop. Does this import everything from IPC? No, but I need to call it as IPC dot IPC dot OS serialize dot parse stream, basically. Parse stream. Actually, just parse. Not here. Sorry, I'm dumb. The DCP stuff is here. Do I have pprint here? No, let's do that. Proplan equals. Let's prefix this. Blob is equals join self prop data, set prop length blob, sigma prop. Something like that. And then we want to print that. Blob is b quotes, join self prop. Yep, that should be pretty much it. DCP. Okay, I think that should work. Let's see if I got it on the first try. Oh. Let's see if that still does the right thing. Let's put this on the left. Okay. Third offset equals double equals. Third offset double equals. And oh, what's that about? 591. Oh, I need to. Oh, yeah, because I changed that. And that was in utils. Oh, did I have a thing? Yeah, and I should have from utils import star. Huh? Oh, it is not exported. Color instance v type. Yeah, 4cc. It's not a type. It's none of those things. Interesting. Yeah, that would happen. Okay, almost there. Ooh. Whoa, weird. 16 BD and then 0, 1. Wow. So it's off by 1? Oh, that is dumb. Why is it off by... Seriously? That sounds like a bug. And it's aligned to 4, so this doesn't make any sense. That sounds like they have a string somewhere with an old termination that is dumb. Okay, getting there. Parse I think it needs to be an instance. Okay, there we go. And then I forgot to return things properly here. It's yeah, I forgot that I need to return the last and stuff. Okay, getting there. Unpack, non-iterable, non-type element. I'm missing something there. There you go. A non-type 10. Interesting. Did I mess something up, or is that really a 10? Is there a 10 here? There is data. Okay, so what is data? Interesting. Let me dump this out to a file and just take a quick look. I'm looking for tag 10, which would be something like OA000, something like that. Oh, sorry, the other way around. Okay, there we go. That meant data. So what is that? Is it just like a binary blob, so like not a string, but then it has length 20. That looks, yes. Yeah, okay, so it's just binary data. It's a bytes, basically. So just that. Okay, and then we have last equals I size minus 1. Is there a bug there? Okay, let me print. Stream.tell #x. Let's do a dump of that. Just do it like this, a little bit better. No, STFU is not sudo. STFU is just redirecting all the streams that no. Ooh, forgot that's not how that works. Let's dump that. Not the return, but just the bool. And then I need, would be nice to have some nesting here, but I'm too lazy to do that right now. Ooh, interesting. HCR static metadata types, type 2. And then it gets... I do want a nesting now. Let's put it twice there. And parse stream, and for this one, parse object stream. Okay. Get a bit of extra spacing there. Okay, color elements, Score that, ID that, ID that. Yeah, cool. Then just segment types. Oh, okay. So the valid key is also okay. So probably this. Though, is that how it was on my sample here? 7 element dict, but it isn't though. Interesting. Is it different? Did that change? No. Oh no, that is. Here's that metadata types. That's false. Yes. Oh no, yeah, that is correct. And then the last one is true. Last that equals I. That should be correct. Oh, I'm dumb. This is overwriting that. It's not last key. It's just key L, assert L, assert not L. Because otherwise it's going to kill my proper. I think that's the problem. Yeah, okay, we have a different issue now. This is from parse object. Return. Oh, yeah, that doesn't happen. Aha, I think that worked. Cool. So let me just get rid of the prints. Ooh. Cool, I think that worked. Let's look at the properties that we got. Property, DCP, prop chunk. Yeah, here we go. And color limits. Oh, that didn't work though. We got nothing. Why? Don't need the dumps anymore. Sorry. That would help. Yeah, so some of it, the ones with the dictionary work, that the arrays are broken. Too fast on that one. Aha, I think that worked. Yep. And this should be everything on here. Cool, lots of stuff. Yeah, this is like freaking giant bunch of data. So yeah, at the beginning we have all that stuff and chunks and calorimetry. Yeah, so this is color elements. 10 to 8 range. Yeah, you have this virtual encoding. Yeah, so we got some scores on those. Some of them have scores apparently. Not all of them. And this downstream format, which I guess has to do with the HDMI conversion or something like that. Did I finish the GPU? I haven't started the GPU kernel. That's like the next thing. But the issue is that we need to get power management working for a bunch of other things that people are working on to make sense. Basically the clocks driver is simple but may not be the right thing to do. And like we can't just do something that works and change it later, because this affects how things are bound in the device tree. And so we need to try to remain backwards compatible as much as we can on that. So I'm going to take a detour to spend a while on power management so we can get a good solid like model for how that should work. But right now I'm just doing a very quick thing that I promised Alyssa, which is basically done already. So this is for the display controller, which Alyssa's working on and is getting pretty far on the Linux driver. So like I reverse engineered it and she's implementing the Linux version. But I promised her this decoder so she could write the Linux version. So that's cool. And yeah, this should basically be done. I'm just doing a quick check now to make sure this all makes sense. But that looks reasonable. The thing is, like, what I was calling clock gates earlier turned out not to just be clock gates. It's more like a power state that includes clock and power gating, and there's at least 3 settings, but they are rarely used. But this is less of a question of how it works on the chip and more of a question of how to represent all of this in Linux properly. Because Linux has a concept of clock gates, but this is a bit higher level than clock gates on the M1. And then it has a thing called generic power domains, and then it also does like frequency and voltage switching, which we also need to do. But basically, you know, I can push something through now that works, but then it might turn out to be the wrong thing, and we'd have to make a big change, and it'll be a pain in the ass. So I'd rather spend some time on it and see if it makes sense. But then again, this also has to do with the CPU frequency scaling and stuff. So although I think Maz said he wanted to look at that. Where are these properties actually coming from? This is from the DCP. The DCP sends this to us when we initialize things. So actually, this is getting set for the timing elements, which are like the basically the modes that are used and for the display output, right? So the different resolutions and stuff. So in this case, you can see this one is 720 pixels by 480 pixels. So these are all the modes basically, and you can even see the short IDs. Like some of these are standard, right? And there's various color modes with different scores. Not all of them have scores though. And then like you get more of them, right? So this is another one. You see the aspect ratios and more scores there. So this one would be 720 by 480 again, and then this one would be 1280 by 720. So yeah, these are all the display modes that we support, right? And so it does all the. It's nice that it does all the parsing of this for us. So it might, some Linux apps might not like not getting an EDID, so we'll see. But then again, there's a lot of devices that don't have EDIDs for embedded hardware anyway, so it shouldn't be a big deal, but it'll be interesting. Here's an interesting one. This is this claims to be doing 4K. I'm not sure how that works because I don't think I have my card can take 4K as an input. So where the hell is preferred? False? Is virtual true? Oh, that's probably why. The previous one is should be a 1080p one. Hopefully. Yeah, so here's a 1080p one. Is virtual true? Okay, they're all virtual apparently. Yeah, I'm not entirely sure where the 4K ones are coming from because I don't think this card can do 4K. In fact, I have the same card hooked up here. To this one, right? And like, obviously, there's no 4K resolution there, so I'm not sure what that's about. This is 4K because it's scaled, but that's because I have 4K screen scaled down to 1080p. But yeah, I don't know. It's kind of strange. Then again, maybe this machine can't do 4K or HDMI, and like the M1 can on these cards. There's no way they can take 4K as an input. Pretty sure. So I'm not sure what's going on with that. I'm going to let Alyssa figure this out because she has an actual 4K monitor. Which I don't. Though I'll probably be, since she's working on a 4K monitor over DisplayPort and HDMI, what I'm probably going to do is I'm going to buy, in the near future, a Thunderbolt monitor, because we're going to start looking into that pretty soon, into USB 3 and Thunderbolt, which is a whole different kind of worms that I'm going to look into. So, yeah. But yeah, it's just weird that there's a 4K. Maybe there's something here that tells you that it's not quite, like, it is overscanned, which is weird. But yeah, I'm sure she can figure this out as soon as she gets the encoding. So, yeah. And she was already looking at this, because she got the IO decode of this already anyway. So that's all good. Then I'm just going to commit this, and that will be this done. Oh yeah, there's I have things that I haven't committed yet. I should move 4cc. Oh yeah, that got moved into ADT because that got into function list. Yeah, I need to commit that later. But let's also, there's stuff here that needs to be cleaned up. But that doesn't matter for this. For this, I could open the iMac, yes. I started making an ARM for it though. So let's do the DCP stuff. There is a spurious space there. I just haven't figured out where to put it yet. I probably will get an arm and just put it like on the side of my computer here temporarily, where the Mac Mini is. Yeah, I split that. Actually, just remove this for now. Do that as a separate commit, and then don't stage anything there. And then put that into utils. Yes. And then the DCP stuff, and that should just be yes, yes. Oh, that is wrong. That is a mistake, but this is correct. Sorry. Cool. That should be it. Make sure I got it synchronized. Main. Okay, cool. And I should commit the other stuff, which is mostly Power Manager stuff, pretty soon. But for now, you just push this and tell her that that's done. Is she in here, actually? Oh, I think she's not on IRC right now. Oh, she is? Wait, she's not on the... Is she not on the GPU channel, but she's on RE? Come on. Yeah, okay, whatever. Oh, auto stash is a thing? That'd be convenient. Is there an actual short? No. Cool. Nice to know that exists. It'd be nice if it had an even shorter name for it, though. Yeah, I knew this one was going to be a short one. It was just this dumb little parser. We can enable it. I should do that. You can. Cool. Okay. Awesome. Actually, I want to probably global on that. Yeah. All right, so now back to Power Manager. Let me just clean up the ADT stuff I was doing and commit that. Been modified. I think that's just the cleanup. And there was some junk in here. Yeah, pattern domains. Stuff. I know I can automate this, but I just want to make sure that there's no parent path. What's here? Oh, that is correct, yeah. Cool. And that's a 9tech226 or something. Yeah, I think that should be it. On that one, function. Yeah, just making sure there's no junk in there. Cool. I think this is all fine to commit power management and function stuff. ADT. Okay. Cool. So yes, I was looking at power management, and so there's a couple of things to look at next. One is I'm using the hypervisor, and there's actually not that much going on. HP trace P manager. There's not that much going on with the with P manager on Mac OS, except all of the spam with the SPI, which I'm going to filter right now. That's a pain in the ass. But I am only tracing the lower ranges right now. I'm going to trace everything and see how that changes things for writes at least. Actually, do I even have the thing for tracing only writes? Also, that didn't look like it's working. Oh, because I'm not cutting the... Yeah, that's right. I fixed that bug. If I don't do that, it's not going to work. Or is it? I might have broken it. Whoa, that is a weird infinite loop stack. What the hell just happened there? Let's just try that again. Oh no, it's just that every time it does a SPI transaction, it turns the SPI controller on and off, and that is a huge amount of spam. And if you filter that out, it doesn't actually do that much more other than that. Like the power management control, register writes that macOS does are actually fairly sparse, except for a huge amount of spam with the SPI controller. Let's try that again. Unless I broke something here. No, yeah, it works now. Interesting. It shouldn't totally break if the other thing is not open. I don't know. Oh yeah, you can see here that it doesn't actually do that much right now. But it's going to start spamming the freaking SPI thing pretty soon. Yeah, see. Now. After this, maybe. Oh, it's not that much right now. It'll come. It'll be a lot of spam. Yeah, C. Oh, sorry, I scored C. And I think it was both I scored C and SPI. So there's some I scored C stuff, but it's not that bad. But you'll see there's a moment where it just starts spamming the SPI code. Linux should do that. In principle, Linux should toggle the clock gate when the UART is, for example, opened and closed. I don't know if the SPI driver does it, though. But it could. See, this, basically. But there's more. I know there's more coming, because there was way more than this. Or maybe not. Maybe it wasn't that bad. Maybe it's only sometimes. Maybe it's because that time it... Oh, no, here we go. Here we go. There's the SPI spam. It's going to do that for a while. And it'll keep going. And so, yeah, I want to not print those. So basically... Or was I doing only the reads? I forgot. Yeah, here's doing that. So they're not really PS regs, they're gates. So I'm going to rename those to gate. Actually, was that in the ADT too? Yeah, it's not gate PS reg, it is PS index or something. Yeah, that makes more sense. And clock gates, power gates, yeah, that's fine. Oh, you mean Corellium's driver? Yeah, Corellium's drivers do a lot of things wrong. So I don't consider them a useful reference for what the correct thing to do is. They're very proof of concept-y. Like the way they did the Thunderbolt stuff. Oh god, there's some horrible hacks in there with like a fake clock driver that then calls into the mailbox. I don't know. There's some stuff in there. So yeah, what was I doing here? So these aren't gates. They are state regs. Dev name dot ps, and then these are actually power gate, and these are ps. Hold on. PS regs. Okay, this is PS. Just call it like that. Really, it's not really power gate. It's just PS. Power gate something. It's got P state. And def gate or def PS def PS index. Just got index. Hold on. 8 times 8. Yes. Call this index. You notice it is a gate, but it makes more sense to be consistent with that. And then let's P state. The thing about clock gating trickery is that, like, with the driver not doing it is fine, but we need to make sure it works, and we need to make sure the bindings, like, the remain backwards compatible as we add these features, and that's the tricky bit, right? Yep, P manager is power manager. Actually, I realized that. Sorry, you probably weren't seeing that very well. Yeah, so spy1.gate is one we're not going to do. And so, in fact, we're not even going to do it here. What we're going to do is... then we just delete that from the ranges. Otherwise, set it. And then we trace the first this many things. But that's called on init, and then that's still going to get traced. It's still going to spam. So I'm going to add an ignored thing here. Actually, we don't need to del that, but let's always leave it there, but just add it to actually start size. and just detrace those. I'll reboot, try that again. And so yeah, if you skip the spy stuff, it's not actually that much. But there's a lot of spy stuff. Oh yeah, and then the other thing I want to do is actually let's trace reads to and then it'll just be just be X. Just do it like that. Oh, but this might not work for none, probably. Probably not. Yeah, thought so. How do I do this? Actually, yeah, let's just do it like this. Alt equals, okay, let's get none. And then only if it's not none, then do we do that. Okay, and that's going to be convenient. This will tell me when things turn on and off and how they turn on and off. Oh, but I'm dumb. But I also failed, so let's go after the callback. Gate is not defined. Yes. Ranges. It's not gate. Index. Run script. Trace manager. GA is not defined. Yes, this is gate address. And then I piece of dev gate. Where is that? Here. Ranges, not append. It's yeah, it is append, but with parentheses. I tried error none. Okay, so it wasn't on trace mode. What do I call that? Off. Cool. Oh, I'm dumb. I hit the... And now it's going to fail there. The thing is, it depends on whether we actually save power or not, right? And that's the other thing is there are power monitors in this chip, so that's how we're going to find out if this makes any sense or not. That's not working, though. It's working sometimes, but not always, apparently. So sometimes it writes and then it... oh, yeah, I guess I'm not doing that. So I need to write cache, return if it's a read, otherwise cache it only after the write. Yeah, so whether it matters or not, if we save energy by doing it, it makes sense. If we waste time and therefore CPU energy by doing it, it doesn't make sense. So that's something we need to identify later. But the thing is, it makes more sense to do it and at first, because then we know it works. And then if we decide that it's actually more energy efficient to leave it on, it's easy enough to change the driver so it always leaves it on. That what we don't want to do is ignore power gating initially and then realize that something is wrong with the bindings or our approach to power gating, and we can't make it work in a feature driver, right? There we go. Now I have nice numbers here. So you can see, yeah, it's like, for example, see this one? This is going from clock gated state, which is 4 to 0, which is actually power gated. And the interesting thing is that bit gets set, which I don't know what it does. Like this, it gets ORed to the 3 there somehow, so I'm not sure what that is about. And this, the spy, I think spy actually did get properly ignored, which is nice. I probably want to ignore I2C2. I2C2 is annoying. Other than that, there's not a whole bunch going on. It's kind of interesting that it does like multiple writes each time. So let's do another run. I'll show you how that runs. So here's an interesting one, actually. I just saw JPEG. So it like turns it on first, and then it still keeps it on, but like it changes a flag, right? Like it adds this 1, and then that makes it clock gated somehow. You can see here, right? Like 34F. So it's like this flag turns on some kind of automatic power management, which is interesting. So I wonder how that works. But yeah, look, we don't have nearly as much spam now, which is cool. I really want to know what some of these bits are. I think that's a reset or something. Yeah, see, that one has that bit again, and now it's clock gated. So it might be that we don't even have to do clock gating ourselves, that it's automatic. But I wonder if that works for all peripherals. So that's one thing that I want to mess around with. I have the tracer now, but I want to make an actual pmgr peripheral for Mini, like a driver, and just mess around with things and see how it works. So let's do that. Let's just do a few experiments and see what the bits make. And I don't know if everything supports that automatic power management thing, right? So, but then the other thing I wanted to do before I get there, since I'm doing the hypervisor stuff now, is first of all, let's actually trace everything. Also reg 1, yeah. Yeah. I mean, I already have a bunch of these, right? In hardware, ASC, Dart, SCP. So, but first of all, let's see what else is in the other pmanager stuff. And I think this first two ranges are the important ones. So if I do more than those number of bytes, then we'll get some interesting stuff there. Yeah, see, there's not that much, actually. There's some stuff there, right? Happened there. So that almost looks like a bunch of things got turned on, like, directly. It's not that much, though, which is nice. So there's some interesting things going on there. Including, these are B states. Yeah, like, what's going on here, right? This looks like it could be voltages and clock frequencies. Well, this is interesting. This is like incrementing now. Yeah, interesting. So what's this about? These 0-1 things look like some kind of clock gate or act like a raw gate, not a power state. But then this thing that's incrementing, which is quite interesting. Wait, why is this a 4-byte write that is... What? That doesn't make any sense. How is this more than 32 bits if it's a 4-byte write? I'm confused. Is that a bug? Oh, yeah, I think I know what's going on there. I think I'm just not masking in my in the hypervisor. So like the CPU register has stuff in the top bits, and I don't mask it. Yeah, I'm pretty sure. Like it's just getting truncated, but it isn't. Okay, let's do a quick detour into that. Also, like it's stuck somehow. What is it doing? Is it actually doing things? Is it just slow? It might just be slow. It might be doing a lot of reads, and that's why it's slow. Since we don't print them, but we still print the writes. Probably, yeah. Yeah, it's probably just very slow. So I should set those to trace. Yeah, I don't know if I can do that actually right now. I think I can. If I do, if I should have that in the trace in it. Size mode quarks event RW, yeah. Yeah, So only do reads for those. Then do reads, only do writes for those. Do reads and writes for everything else, and then ignore it and it just goes off. That looks very slow. Yeah. Thankfully, I can do that or not. Oh, yeah. At tracer, I read. Oh. Because of that. SP manager. Am I doing the reload there? I'm not. We need to do that. Yes. Much faster now. Yeah. So let's fix that hypervisor thing with the wrong masking. I'm pretty sure that's in here in HVVM, where I do the... So my read should be fine. It's just the writes, because those come from the CPU, that are not masked properly. So emulate store val is regs RT, right? So the problem is the width. Basically what I need to do is... The width is in mod, so 1, that width, it won't be 1, it'll be how many bits? 8, yeah. And it'll basically be that -1, but the problem is that that's going to overflow over 64 bits, but that's fine. Because it's still going to get I think that's the right math. Yeah, should be fine. Yay, we're getting there. But reboot. Let's try that change. Ooh, right, with start with, and then I need to actually let's just do it separately. And I think that worked, because I don't see that going off the rails anymore. Well, we'll see now when this gets big enough. Yep, properly masked. Cool. I'm just going to commit that real quick. Put the white space. Let's just make this thing save. Make no white space. This is not a one-man project. I'm just the person who started it. There's a whole bunch of people working on this. Getting there. So yeah, I'd like to know what those registers are. I know some of this probably has to do with the CPU power states. But it's interesting that it's doing those incrementing things. So I wonder what that's about. I feel like this one keeps going up and down. It's kind of weird. 3, 3, 3, 2, 3, 5, 3. And then the other one always goes up. Okay, so it's actually booted now. It's just still doing that. It's not that fast, but... So let me look at the Corellium stuff that has some CPU. Yeah, this stuff. Just to figure out what registers those were. So it's a 2K. RIQ 0 cluster base, and base is what? HCC base, and HCC is where? HCC is the cluster, and then the cluster stuff. How many years of experience did it take me to start working on these projects? I mean, I've been working on this kind of stuff for a long time, but I don't know. I guess I was doing serious reverse engineering since about 15 years ago, something like that. But it's not been like fully continuous either. Like it's sometimes I have a project going on, and sometimes I don't. It's doing a lot more stuff now. I wonder what this is. 38004. It's pretty spammy. So let's see. It's fine. AC base, SHC base, and HC is IMAP resource. So num bases. How many bases is it getting? So there's one for each cluster apparently. 3. Okay. ICC base cluster P manager base. Is that the third one? Yeah. So there's 2 for the clusters and then 1 for the P manager base. And term 64 boot DTS Apple M1. A few frack. Wait, why does that have 4? Thanks. Cardiologist says happy birthday. So let me do a quick notes thing here. So we have 2010E is 11E is cluster 1. I think those are related to the CPU things in the Apple thing, and the CPU start, Apple start 2. Yeah. See, 2010. Or not. Actually, no, it isn't. Because that's missing that 1, so it's different. No, it is. Sorry, 1082. Did I just? I ate it. Oh, what? Did I just eat a 0 there? No, did I just eat a 0 there or anything? Or hold on, what? Oh, because I moved it by accident. I'm dumb. Yeah. Yeah, so it is like that. Yeah, I mean, hardware. The thing about hardware and software is that, like, when you get to this kind of drivery stuff, you kind of need to know both worlds. So it helps if, like, when I was young, I did a lot of like microcontroller projects, like even before Arduino was a thing, just kind of raw microcontroller stuff. And so that gives you, and then like messing with game consoles and other embedded systems, and so that gives you an idea of how this is supposed to work. And so it's less intimidating when you've been doing it for a while. Yeah, so we know this is pmgr. That's not new. And then we know this is something. What is that? That gets added later. I think that might be from the next commit they did. Hold on. Maybe the frequency control. Yeah. Yes, this adds another base, and then it's the DRAM thing, isn't it? Yeah, MCC. So that's MCC. So that's about the RAM stuff. So I'm just going to look at what the current thing is doing here. But basically, I'm interested in the pmgr. CPU gating is NC80 is CPU gating. And then for 8. So yeah, let's do these. Let's dump these in here so I know what those are. And I'm not looking at the cluster stuff yet. Interesting, it has like set and get. Oh, is that only for the index? Is that how it goes? So it just has the it just uses the target index. Okay, so that's just where yeah. There's not that many of them then. 20 plus. Oh, okay, interesting. So it's got like a. I should just dump stuff from that. That's the MCC stuff. Gonna dump these things here. I'm just gonna save this somewhere. Let's just call this notes.txt. It is doing a lot of stuff now. 38004 is what? It's not here, so we don't know what that is. What else is in there though? 3.9 is that's also another one we don't know. 4.8 is actually the one that had the core stuff, but it's not. But macOS is not touching that though, which is interesting. Because I think I'm tracing that. Let me look at the ADT real quick. Uh, 3B7 10.0.0. Yeah, it should be. Oh no, I'm not. 10. Yes, I am. Yes, I am. Should be tracing everything. Yeah, the clusters are the performance and efficiency cores. It's the big little thing. But there's like I mean, there's different power states for each. But see, the interesting thing here is that macOS is not touching these registers right now, and I would expect it to. So what's going on? And what's 38004? That's a really good question. I see 5C now. That's still something I don't know about. Okay, so let's not trace that. Because that's, I don't know what this is, but it's kind of annoying. I'll just put it in ignored ranges, really. That's what, just put the whole thing in there. Yeah, there we go. It's much better now. Yeah, so it touches 3.9 and 5C stuff, but like, why is it not touching the core control stuff? So the thing is, there's a subcore doing some power management, and I wonder if it's automatically taking care of that stuff. So one thing we can do is see if those are changing, even if we're not. So let's add actually let's just add the range tracing for the cores, which is here, and should be at least a lot of stuff actually. Let's do 7. Let's do 8. 11E. Let's do the MCC2. That's a DC4 and DC. Oh, there's a bunch of lanes. We'll do MCC later. Okay, so it's doing. So those are also MP Manager anyway. So it's reading a bunch from. It is reading from P state. Where did I find how I determine these register values? You mean the values? I don't know. I mean, this is from, these names are from the Corellium driver, but and I don't know how they found them. But if you mean what I'm getting here, this is a hypervisor that is sniffing everything macOS is doing. So the question is, what is this doing? 25.225. So the PS info is setting the CPU frec. And then it does a set volt on V control if necessary. I mean, if you look at my other streams, I've figured this out for other devices. But basically, you look at the values being written, and you start making guesses or try to try things and see if they make sense. The Apple device tree contains the if you mean the start addresses, that's in the Apple device tree. The offsets though, that you kind of have to work out yourself. PS info 1 2 so 7 to. There's a lot of reads, but are they any writes? Not really. 3.9 at B9. We don't know what B9 is though. That's the thing from before. Yeah, so see, it's reading stuff, but it's not writing anything, which doesn't really make any sense. Yeah, of course you're going to time out. So okay, I'm going to start skipping things that I don't care about, like these. We don't know what these are yet. Yeah, so 240, 10E, 4.4. Yeah, again, not... Oh, 4.4 if fate is in there. But this isn't writing to that. It's just reading from everything. Okay, let me just do... where am I? Mini HV. Can I do only writes? Is there? I don't know if there's a thing. Mode. I guess it wasn't. And yeah, let's just do writes only. Yeah. There's an error. This one off. Or read or write. Oh, right. Cool. Why am I still getting reads on pmgr 5 and 6, 410E? Because I'm dumb. Get that in here too. Aha, there we go. Cool. And now it's just writing to 5C100, which I think we also don't know. Yeah. It's actually just writing the same value over and over again. Looks like a power state. So that is slow all of a sudden. So it is possible though that the power, the CPU frequency stuff doesn't work because I only have one core enabled, and like it's very confused about that. That is totally possible because the hypervisor does not support multi-core. The thing is, the tool that shows that is dead. So I might have to end up actually implementing multi-core in the hypervisor to properly figure all of this out. But for now, this is all done. So I want to look at the That was that tool. Pill M1 CPU frequency show or something. There was a tool, but yeah, it's crashing on here. Yeah, power metrics. That's what it was. But I'm pretty sure it crashes because of. Yeah, see. I wonder if there's another way of doing this. Does any of the benchmarking stuff show it? The tasks works at least. It just crash. I think it's still doing stuff, just slow. I think it just crashed or something. Or does it say it died? Or something. Probably still booting and doing crap. Yeah, it's still doing things. Yeah, this to the ignore disk because I'm getting annoyed by it. Yeah, just like faults. Or because there's like no P cluster or something. So let's do what I said. Let's just read some of those registers and see if they're changing. So the cluster, the P cluster will not be used, but the E cluster should be getting used. Also, 3PU frequency. Is it going to be the same for the whole cluster though? No, it should be different. The voltage will be the same, but not the speeds. So hold on. Go back to the Corellium thing. Yeah, PS info, right? No. Really? Is it? Nah, it should be. Hold on. Let me just pull up the laptop and look at it on a different machine. Yeah, obviously the frequencies are going to be different for each CPU, and in fact they are like totally random. They are definitely very variable. So the P states are probably, and there's also 0 megahertz things, right, when they turn off. Yeah, this is very fine grained. So I'm getting the feeling that this whole driver is bunk and it's messing with things that are actually offloaded to a different core by macOS. So let's see. Let's see. So let's look at those things and see if they're changing. At least the power state should be changing. I mean, either that or the thing with the, it being one core is breaking it. V control set volt. So let's see if the that just turns the bit on and off. That's not useful. But what I didn't see is the PS info, I guess. That's 0. That's something. Okay, so PS info 2 is something. And then we go to 08. Okay, so you can see that's always D. Yeah, okay. Oh, the zeros. Okay, those are interesting. Yeah, so there's definitely things going on 0. I think it ends there. Yeah. Interesting that the these are all basically probably because the E clusters don't do any kind of special voltage scaling or something. But so that's that. And so then the question is 210 and 208. So let's try using the CPU. And then read that. Oh, it's still 0. Doesn't change. It does do that. There's not much saying there, though, that that would be wrong. So I'm going to try something. I'm going to reboot. No, the window the top corner is the real M1. It's not emulation. It's just HDMI out. It didn't settle as far as I know. I think what happened is that they Apple lost on something, and then something else wasn't decided, and then they appealed, as far as I know. So like it hasn't been settled yet, as far as I know. So yeah, what I'm gonna do is so CPU one. So what if I don't remove these, but still pass CPUs equals 1? Can I make it Can I make it like somehow know about the other CPUs even if it doesn't start them? I wonder. I don't like it stopping there. Oh no, it's still doing things. Ah, so this one, there's a cluster piece state getting written to now. So maybe that helped somehow. It's getting to 0 though. Okay. Yeah, that's new. So maybe that did help. Dare I say it's faster now? I think it's faster now. This might actually have switched power states. This still takes photos though. It does try to read some stuff there. Oh, it's just expect. But if I cut it though, it's still nothing there. So okay, so reading that and that. 208 was it? Where am I? Did I forget to paste some stuff there? Oh yeah, I did. Or I deleted it or something. 210 and 218, sorry. 210 and 218. There's R0 now. It's still 0. Same in the other cluster, as you expect. Oh, wait, are these 64 bits? I think they're 64. Oh, okay. Hey. Well, it's R0, though, so maybe they're only for sets. Okay, yeah, clearly. Yeah, so it is changing things. Kick started out of mem2. You mean like when running under libogc? If I mean you could use mini, but then you can't use the libogc. So there's no like it needs the memory, right? So let's see. 200 and 210. Do out of 200 and 208. There's isn't really anything there, is there? Okay. Ooh, what just happened there? Oh, I got an S error. Interesting. That does not look right. Did I just break like RAM or something? I think I just broke something real bad. Interesting. It's failing reading from the second. It's like one of these reads broke it somehow. But now it's working though. That is weird. Oh, it's a pair though. It's an LDP. Is there something about how I emulate that? Let's read separately, but I mean, I'm not sure what happened here. Just reboot it. Do I dare try to implement multi-core in here? I really just need spin locks. It's not that hard. I can just have a big hypervisor lock that just locks around all entries into the hypervisor, and that'll make it work. Hacky, but it'll make it work. It's just I still need one core for the watchdog though. But I can just turn off. I can turn off the watchdog though. Don't need that anymore, really. Wow, that just... Huh? I feel like there's a bug here somewhere. This doesn't make any sense. Plus, now it's getting fault on an ad. That doesn't make any sense. What? No, I feel like I got an error with this read, and somehow that broke everything. Let's see, but that one is a proper... Oh no, that's because it's unmapped. Oh. That's why. That's why. That's why. And now it'll work. I see. Yes, we need to unmask at least S errors from the hypervisor because those matter. Oh, yeah, something's weird there. Okay. Yeah, everything gets maxed on entry. That's why. So basically, the way I want to do this is to unmask S errors on entry to Python. Because by the time we get into Python, if we get an S error, like if we hit an S error inside the hypervisor, it could be the guest's fault. Now, you know what? Let's just always do it. And I want to clear 8. Apparent one, not MOV, sorry. SR. That makes more sense. So, no, it didn't work. Was that debug? Did I get the wrong number? Yeah, I got the wrong number. It's 4. Yeah, okay, now we get this here, which is what I expected. Yeah, okay, cool. And those are zeros, as you would expect. That's not a thing. Let's keep booting. Which it is, right? Yeah. So there's a better way of finding out the clock speed that doesn't involve that tool, which is crashing. that bit 42? Yeah. So what is lock control? Here's set. So it sets lock control, and then sets CPU gating enabled. Wait, hold on. This is weird because... Okay, no, it is correct, yeah. Yeah. Dot instead of a colon and Spanish thing in times? What do you mean? Oh, like for hours? I think that's a Japan thing because I have my... I think actually, I'm not sure what I have the time. It might be the... Hold on. Yeah, it's the Denmark thing. I set the LC time to end Denmark. I believe that was to get the time format to be the right thing. So I have quite a mixed up locale. Because if you set the time locale to like Japanese, then you end up getting, like kanji for morning and evening and that kind of stuff, which I don't want. But I do want the year, month, day format. Though this one isn't showing it in that format. No, I don't know why. I think this one is, yeah, date format. So this one in particular is overridden anyway. But like there was a reason for this. Also, this is now showing it in like ISO format, which is confusing. Okay, now I'm not sure anymore why that happens. I do have NDK. I remember that was a hack I found somewhere, but now I'm realizing that this is making it do ISO, which doesn't make any sense. So I'm not sure what's going on there. Obviously NUS gives me that. Oh. And if I use like Japan, then yeah, then you get it in like kanji, which is not what I want. So let's see. Let's see if I can get the CPU frequency some other way. Probably want to pin that too, to be honest. Why is the CPU usage? That's not what I want to do though. Okay. Yeah, that doesn't show the frequency though. Okay, let's just try detrussing that. It does feel faster now, so. And it just dies. Lots of advice, and then, yeah. Oh, there's a power metrics internal. if it's a thing, I guess it looks for it. Interesting. Yeah, it gets hardware and CPU. And it's unclear if it probably really hates not having all the CPUs. Thing is, I should eventually add multi-core to this anyway. So maybe now's the time to do that. Let's see. It's 6:30 p.m. here. How long does it take you to add multi-core to this hypervisor? It shouldn't be that hard in principle. Famous last words. So let's see. I need a spin log for ARM. It's not a load though. Might as well just use atomics, yeah. Actually, yeah, you know what? We can just do it in C. Because why not? I'm try to do this with a bool though. I would do this with at least a 30, probably 64-bit makes more sense. So let's just do a dumb atomics spin lock. Well, let's see if I can get spin locks implemented and the hypervisor multi-core in 3 hours. Let's see. Utils, ASM, not ASM actually, it's just going utils. Oh, it's a byte actually, but I don't really want to byte distance. Well, I guess maybe it's. It's basically compare exchange is what I want, but not really a bool though. What I want actually is actually let's just do let's do 64 bits. Probably want this just in case. Sync lock test and set. That's the same thing, though, isn't it? Yeah, I mean, that's the same with the atomics, though. We had a test and set there, right? Hey, bump the font a little. Oh, sorry, yeah, that's I forget. It's kind of a cape bug. It's supposed to start off larger, but for some reason it doesn't do that. But yeah, that might work. Yeah, I guess that'll work. But it's not using memory model stuff, though. You kind of want to be able to use these memory models. I think this is fine the way it is. It's just that instead of test and set, I would want like a compare exchange. Anyway, let's just leave it. This should probably work. Let's just leave it like this for now. And spin lock T lock. I want this to be lock. And does build at least. Actually, these should be inlined, probably. It doesn't matter, I guess. Not for this. Utils H. Let's put these in here. Yeah, that should be in here. So the tricky thing here is going to be we have core stacks, so that's fine. Each one of those is going to be in hypervisor in its own stack, so that's not a problem. So really, basically, just all of these do breadcrumb E, entry, exit, breadcrumb E. The old do exit, right? Yeah. Yeah. big hypervisor lock. Declare skin lock. Cool. So that shouldn't break anything for now, because we only have a single core anyway. So that's step one. Make sure it still works. And then I probably should... well, for now, we're only going to give it a few CPUs, and the hypervisor is going to still use the watchdog, which is not open right now. The watchdog runs on which CPU did we do that? With the CPU, which is just defined as 1 here, so that's not good. Let's put the watchdog on 7. The funny thing is that I don't have my serial port hooked up right now, and it works. We're good. So yeah, but debugging this stuff is gonna suck. So you have start, stop, init, breadcrumb. Yeah, so the breadcrumbs are fine. Pit stuff is fine. Basically, just the main. Basically, we'd call this right now an HV start, and we should call it in from Python. And then in HVW, dt stop, SMP wait, CPU. If it's active, then and we want to put this in the proxy. And we might as well pass it the CPU here. Yeah. Still been there. Cool, get that, and then here for now, before we start. That should do that. So that'll disable the watchdog for now, which hopefully won't break anything. So let's try that again. Is that done in the run guest? Oh, was that done in the hypervisor init? Yeah, it does. Okay, HV init. That's fine though. So that will be running the hypervisor without a watchdog, which should be fine. Yep, that doesn't look like an issue. That is running, right? Yeah. And then, cool. So then we need to do the hook the SMP start stuff, which is the same I use here. That should be handled in the Python, to be honest. Yeah, Linux might be quicker. That's a good point. Actually, just running mini and letting it start secondaries would be easy enough. But basically, the CPU start base, just hook that, and we can do all of this in Python too, so. Let's see, in it. Map viewer, that's the tracer, and then I really want the init stuff. Map essential, yes, this does that. And those are you start base, which is pmgr plus CPU start offset. And that is reg 0 of pmanager plus CPU start offset. This isn't pm, it's pmanager actually. Should be 0. I think pmu, I'm calling pmanager. I really should use the pmgr base for this. Yeah, we do it like this. And we need how much? Plus 4, 8, and C. I don't know if it touches any of the others, actually, but I guess we can just hook everything and then only look at those. It'll be interesting. Reads, probably don't have to care about reads. Just do it like this, I guess. And the V-bars are right. We can just let the guest write the V-bars, because you don't lock them anyway. And what else? Just read. It's easier than emulating those registers too. So, in that case, basically just if offset is greater than 8. Width equals these should be scaled widths, I believe. Yeah, 32 and stuff. Yeah, with this 32. Something like that. Oh, okay. Actually, I might call it more like start secondary cluster I. And then for that, first I need to figure out what secondary this is. What I should do here too is if there's a watchdog set, then only remove that one. This gets called when? In init. Yeah, so I could still change it there, so that's fine. We don't really need this anymore. Actually, we can do this like this. And for now, always enable it. Damn it. Pass. And then just set SMP to true here. Cool. Oh, what the fuck just happened here? Damn it. Oh shit! Did I just accidentally like clang format this? Shit. Crap. I think I just clang. Fuck. Fuck. That sucks. I accidentally hit Control Shift F when I was trying to like search for something. Control F. Okay, I should make that not do it on Python files. God damn it. Show tooling for mine types. Yes, that. The text is probably fine. Yeah. Okay. Yeah, see, now it doesn't work. Okay. Here. Yeah, obviously this is actually not that bad. Obviously that. That one's fine. Where the fuck that happened there? Oh great, you that didn't work. Hold on. I can't undo because it's saved. It's not. It doesn't go into the undo stack. See, it's not an editor thing. It like saves and runs the tool. So Why is that? No. And then that's fine. And that's also fine, except for splitting that. I'll just rewrite that. Just undo that. Oh, I just undid the CPU thing. Yeah, definitely undo that one. And that. What was that called? WT start or start WT beginning? HDWT start. Yeah, so basically for name in these are fine. Okay, that makes sense. And then if SMP, then remove everything. Cool. And now I just need to do the secondary start thing. Okay, cluster CPU, and it's really just going to be calling it on the. I don't think registers matter for secondaries, so basically. Give these things in. It was not done yet. It'll be the same as HP start, but with an extra CPU. Entry args, yes. Let's go to CPU. And then in hv.c and hv start. We can just let start secondary initialize everything. Okay, start secondary, and so the trick here is going to be all that GXF and crap has to happen. We need to do a lot of copying here. Interrupts are going to be tricky though, because I need to. The tick thing has to happen on all CPUs to make the. Yeah, that has to happen on all CPUs, which is going to be a bit of contention, but it'll be fine, maybe. Actually, there's going to be stuff here that is not SMP safe, like these. That's the sanest way of doing this. I need to like. Let's see. These have to be per CPU basically, but what's the same? Am I going to implement per CPU stuff in this too? I really don't want to do something like that. But what I can do is I think I'm using TPIDR for something dumb here. Yeah, I'm using that for the exit thing. So instead of using that for the exit thing, what I can do is use that for the CPU, enter guest, puts that in SP, and then TPIDR EL2, TPIDR2, probably want to use that for the CPU index, so let me think for a second. I can just put this in hv.c, I think. Let's just do a... do we have a max CPUs in here? I think so. Yeah, max CPUs. I do have SMP.c here. And the right way of referencing this stuff, it should do the...
An
HV enter guest should also start taking a CPU. Oh no, TPID will do it. So we'll use that. Can we use X7 here? Probably. Is that how it worked? As he forgot that. Looks like it. I forget my arm for indexing. So this will be something like that. Then yeah. I forgot how the indexing works on ARM. Until how often I actually look at ASM these days. I think ARM64 supports this anyway, because we'd read them if it doesn't. Where's the... Yeah, but no. Yeah, it should be like that. Oh, it's comma. That's what it was. Yeah, okay. And then this is secondary. Yeah, that's right. Okay, so I almost had it. So takes the TPIDR, loads save SP, moves that, and then indexes. Yep, that looks cool. And so then for returning, though honestly I never use this anyway. It'll just be LDR. Yeah. And so then in HV start, I would do, that'll be CPU 0. HV start secondary, yeah. And so here, I do want to pass the CPU off to the secondary so it knows who it is. Do we have an SMP who am I or something? No. So yeah, that'd be nice to do actually. Why don't we do that in the SMP code? Sounds more useful. Target CPU, yeah. And then in that case, the CPU 0 should have a... So that should be somewhere in startup pretty much. And so here we don't need to do this anymore. And this doesn't need to do that anymore because it knows who it is. And so in this case, this needs to copy a bunch of stuff from things here. So if GXF enabled, that needs to be enabled too. And then we need a bunch of things to get stuff copied into the secondaries, which really should be in SMP.c. SMP.c. And let's see what stuff we do here. We probably want to, yeah. Yeah, so basically HCR. HACR. MDCR, MDSCR. Was I doing this properly with the proxy? Yeah, it calls wait for sync, yeah. So I need, the MV thing is wrong. Wait, memory. Okay, so that'll be here. Actually, that can just be HV enter guest, right? It would be the same. Yeah. They clear. Yeah, that looks reasonable. And then we actually want a spin lock here. Should be fine with this because we're not actually doing anything. That's MDCR what? Should be fine like this actually. Do we have the AMX control thing? ARM CPU ranks. No. And then that was actually using APSDS. Yeah, just APSDSL12. And then in here. Oh, it should be imp apple for these things, I guess. Why aren't we printing that properly? Oh, there was a dash thing going on there. HPC. Is that how it worked? No, that ACR equals. Did I just? Yeah, I forgot some commas. Cool. So that calls that, and then start secondary will be. Something like that. Commas. These are commas, not semicolons. Okay, that is not in here. No, it isn't there. Just not including. Pointer from yeah, sure. SMP call 4 really was that? Yeah, it was 64 bits, wasn't it? Sure. CPU wait, too few arguments. Yeah, CPU of course. Entry, yeah. Go for, yeah. Okay, cool. And now MDSCR, they get probably got the EL thing, it's EL1. Yeah. MDCR also, right? Or not? Or not? And then that APSDS EL1 too. Okay, getting there. And then here in memory, SMP, format, SMP wait, CPU, of course. Okay, that seems to work. And then here, so the one thing is that exiting the hypervisor isn't really going to work now because we need to somehow exit all the secondaries and then return from the main one. And I don't really have a good... I guess basically what I would do is I need to call exit guest from this one, but then I need to like somehow interrupt the others. So basically then what I would do is HV init, HV start. What I probably want to do is how does the exit thing work? I forget. That was just the assembly directly? Yeah. Actually, let's just do it as bool should exit. And then an enter guest and start, basically. Yes, yeah, like that. And then an exit guest. So basically, when I return from here, Something like that might work. Oh wow, I don't have to swing the edge here. Typo. Cool, okay, that's there. And then that should basically work. Maybe. We'll see. And then the other trick is I need to check for this in the tick. And then the other thing is on exit, I need to unlock the lock. Yeah. This is not going to work first time. Among other things, because this, first I need to make this like that. And those inits aren't going to work anyway, so... But everything starts at 0 anyway, so that's fine. Those... We do clear everything, so we don't actually need those initializers. What is that? X entry PMGR count? Yeah, everything here needs to be per CPU. Actually, you know what? Let's just do it as TX and TX. I might do this per CPU thing differently later anyway. What was that before? Oh, U64. These all should be static anyway. Stolen time, though, is going to be real confusing because how do you even handle that? That, I guess, should be global, but it's going to be confusing for the other threads. That's after the lock, so that's fine. Okay, something like that. Okay. Let's see how badly this explodes. Is the Python side done? In principle, that's all we need, right? Did I not write that yet? Oh, sorry, wrong file. So I need like the U-boot thing and stuff. Well, I don't know U-boot. Basically, there was that. Yes. So let's see if it works with Linux. But we don't need to make that. Ooh, okay. That didn't work. That is weird. What happened there? Right, CPU start WH. Unmatched parentheses, yes. F removing ADT node. Was that another okay. Cool, it broke. We got a sync exception. But it didn't even get to starting secondaries, so. Also, why is there a hypercall? Huh? An exception and then it goes to. Huh? 153B0? What's that exception? Hold on. Oh, TPID. Oh, yeah, okay, because duh. Only if we are in hypervisor mode, otherwise we don't care. But then it'll be TPID. Oh, is that actually? It should be, yeah, TPID area 1. Is it? Oh, probably not actually. Hold on. Was that one of the forwarded ones? I don't think so. I think it's one of the ones that aren't. Yeah, I don't think so. I think TPIDR is not, so we actually need to consider that. And that would be in, where was this? In startup, let's see. And then, honestly, what this should be is... SMP the and EL2 is, was it utils? I think so. Yeah. Sorry. And then in SMP.c, that should do that. And then where we were using that, where was that? It was an HV. Well, it's only a hypervisor anyway, so I might as well. Yeah, it doesn't matter at that point, does it? Here. There you have it. Seems to be SMPD long in. It's not that anymore. It's just D. Okay. Let's see about that. Okay. The guest doesn't start the CPUs properly. It does get to Linux though. I'm assuming Linux did not. Yeah, Linux did not boot more CPUs because I'm pretty sure I patched that. But yeah, it disables them. What happened there? It didn't work like at all. Okay. So there's a problem with the hook here. It should have been printed at least. Okay, that is getting called there. B154. And it didn't call any of that, which is weird. Did I not hook this properly? Oh, I'm dumb. That. Okay, it still failed all the CPUs and didn't work. Okay. Why is that not doing that? Let me just print the addresses here. Oh, greater than or equal to 8. But that's still not the problem. 23B75408. That is not the right index. Oh, not pmgr, that's CPU implement register, isn't it? No, that's RV bar. Also, where I'm not even jumping to the right place. I'm dumb. But pmgr direct CPU start offset. That is where. I think it's 0. Uh, 3B75. Oh, AI's fuck. Yeah, okay. And then I'm pretty sure I'm not jumping to the right place. Source secondary index entry. Yeah, this isn't even hooked up properly. But I do need start secondary CPU entry regs. Well, I don't care. I need to get an entry here, and entry would be that comes from SMP.c RV bar. Go for reg 0, yeah, and that is uh it's just 0. It's just a single. Yeah. I don't need the ID actually. I just need that. Okay. Node. Okay. Index is not defined. Yeah, I do need the index there. UID. Which hopefully is the same. Is that how I do it here? No, I think, yeah, I do. Yeah, it is. Okay, that doesn't work. That entry does not look sane. Oh, because the top bits have shit. I forgot about that. That did not work. Hmm. Not quite there, but now it's sane though. That's going to. Is it going to deadlock due to interrupts? HV start secondary. No, why would that? Why would that hang? Even gotten to. Is it just because I'm not flushing? Probably. Or not. That is weird though. Oh, what just happened there? Oh, I think it's just on the memory. I'm not sure. Is something wrong on the proxy side? Ah, that'd be that. Okay. That rebooted. Something exploded badly here, but let's see. Okay, got a crash. Secondary. Secondary. Ooh, okay. What the hell just happened there? Interesting secondary. What? That is 1. Okay. The hell is going on here? Oh, that's what's going on here. Okay. Now getting closer. Entering secondary at exception lower sync. Okay. So the other thing I want to do is, by the way, before I fix that, is in the exception thing, let's actually say who we are. We do have MPIDR, but let's do... That was where... I knew it proxy for some reason. I need to move that somewhere else. And HV exception. And that would be here for the same reason. This doesn't make any sense. Or not. Was this PSR? Yeah. And then we don't do that actually. And that is sub CTX actually. Nice. All right. PID comma. I just. Cool. Okay, so that we're properly in a second CPU, and nothing is horribly exploding other than that. So it got an exception accessing. Oh, I think I didn't. Yeah, the hypervisor page tables run setup. The E and HVVM. There's more registers I need to save. What's the unit function? Is it at the top? Yeah, this vTCR and vttbr. These also have to be saved and passed over here in hv.c. vTCR, vttbr. And then I'll probably also should do thing. Or not. Or not. Okay. Hey! Okay, something broke. Okay, there's a timer problem, but I think we have multiple... Yeah. Yeah, we got SMP. Something about the timers is broken, but... Cool. It definitely went in. And it should be here too. Seeing how it does those. Yeah, see, entering gets secondary, and then it does more things. I suspected the timers would break, so that's not terribly surprising. And actually, it'll be pretty cool if I start basically prepending things to all the logs, so it like you know what? Don't have that. It's at a log function. Yeah, I have custom log functions for like the tracers and stuff, but not the core hypervisor, which is a bit now, in H3, yes, but in if you go into the tracers, there I start having like this stuff, right? So I have custom log functions for the tracers, but I never did use it for the hypervisor or like core. So what happened here? It's doing a break. It looks almost like an exception save restore problem. Or is it just like dying there? Probably just wants to be injected into the gas because it like died or something. Okay, so what we're gonna do is not account for stolen time. What just happened there? Yeah. Okay. I think I just messed that up. Oslar? What? Python exception? Okay. Oh, sorry. Keyboard argument. Yeah, I need keyboard args on that. Again. Aha! Cool. It works. So yeah, I don't know what the proper way of accounting for stolen time across multiple CPUs is. But hey, this works. And if I just break it, CPU 5, continue. Seems like I'm on CPU 5. Now I'm CPU 7. So yeah. Yeah. Works. You get a random CPU, of course, because, you know, whatever the next interrupt happens or something. Or the next polling, actually. So yeah, not doing stolen accounting is going to slow things down in macOS, unfortunately, because of like delays. But I need to look into how that is supposed to work. It's not obvious. So, what about macOS? Oh, not CPUs 1, though. Okay. We get an exception. That doesn't make any sense there, though. I have instruction abort. Is that on the startup? It is, yeah. Huh, okay. Why instruction abort? Is it not? Oh, yeah. For macOS, it's different. The RV bar, we need to set that. We need to set the RV bar for the secondaries ourselves. That's the same thing that than chain load is going to do. This. Mini is going to change that, so we still read the registers here, but in the startup here, load Mako, that's probably a good place to do it. That'll probably work. Self P, sorry, yeah. You reboot. The Vogon beeps is always 48 on ARM64. It has to do with the timer clock, frequency, not the actual CPU frequency. Hey, it's doing stuff. Ooh, and the panic, excellent. You have enter options. So also for the tracers, I want to use the CPU log thing. It's definitely doing things on other CPUs though. Interesting. Is that a thing we have? It might be, yeah. Yeah, we have that. PA, that. Interesting. I feel like it's something dumb, like some stupid corruption or something. Let me just reboot and see what happens. If I just do it again, if it's consistent or not. Is it the same? No, different error. Yeah, so we definitely have some kind of random corruption or something. Yeah, I could try CPUs too, but interesting. What happened there? Kernel data abort. Panic thread. Yeah, I think it's definitely some kind of corruption that we have. 4.3 is the one that panicked. Check the full backtrace for details. Why is this printing a what? I thought I added the logs to that. Oh, that's the CPU for the hv.py where's the huh? Wasn't that? Oh, it's in trace. It's in print tracer. Also, there's a print. Just really save self.hv.log, and then the same for pmgr, which is here. Yeah, I did have a print on that. Should not have been a print. Yeah. Hopefully. Oh, I bet I know what part of the problem is. For one, this is a problem. Uh, I don't know if that's the problem, but that's certainly something that was not right. Wow, that was fast. Oh, different. Non-native CPU ID. In log, MIO. How are we getting? Oh, because those don't have CPUs. That has to come from yeah. Yeah. HV log will only work for that. So event default. Are these sync? Yeah, these are sync. that doesn't work. Print tracer, yeah. And then in that case, I should add the CPU ID to the asynchronous logs somehow. UART proxy.h probably. MMIO trace, that's in HV VM. There's a reserved we can use. Though we can just stick it in flags, to be honest. Actually, let's do it 2316. That's some more space for flags there. Are these more of them? It doesn't mean there's width and multi. And right. Yeah, it just says right or not right. It's that. Get it on the Python side. And then it really should be actually just do it as it works. So log, and then in the print tracer stuff, I need to get the MIO trace things. I get up to terminal trace flags, yeah. Sorry, 1624, 2316 is what I called it, right? VM 2316, yeah. And it'll VM, MIO trace here. Yeah, flags. You. So that should just be printable as a EBT here. Okay. Interesting. Kernel data board. It's a null pointer DRF. Just look a little bit through the hypervisor code and see if there's anything that catches my eye as I don't think so. That's for the patch exception handling, but well, I'm not doing that, so well, I probably will though. No object. What was that generic container thing? Did I have data classes in here yet? I don't think so. But I was using them somewhere. Where was I using those? Yeah. But not there apparently. um. Okay, let's see. 1b bar none, and we're going to equals none. I think that works. And then b bar self view. View ID. I think that'll work. That. So let's try to do this with exception handling patched. Let's see what happens. Actually, it doesn't even need maybe like that. Just do it like that. It needs a default factory or something, huh? Vectors, none. Okay, that's working. Unknown vector? Okay, it's already patched, is why, because they're the same vectors for everything. So it should really only be doing this on CPU 0, actually. I didn't really have to do all this. Because in this case, it's always going to be, yeah. That was kind of dumb. Yeah, that's actually pretty stupid that I did all that. It doesn't make any sense. This is going to be the same. Just don't do all that. We need that. It's just that it'll have to be only on CPU 0. What actually happened here, though? We got an exception. Just a hyper call, though. Oh no, that's just huh? Hold on, let's see. Okay, it actually panicked without. Okay, let's do this without doing the pmgr tracing, because that's just going to make everything more confusing. Okay, it just panics without the without going through exception handling. Why? Oh, because I didn't uncomment it because I'm dumb. CPU's one should work. Unless I did something really stupid. So, I mean, yeah, actually, good point. Looks like it's working. Yeah. Yeah. It's getting to user space and stuff. Aha. Error decoding panic. Exception unknown. Debugger break. Okay, so we couldn't get the panic. We think it's a panic. Yeah, that's definitely a panic. I think that's just bullshit for that, so hold on. Couldn't decode the panic, why? Exemption unknown, yeah, no instruction, that's fine. This is clearly not correct, but probably because of the CPU being different or something. Or maybe because this doesn't work on Mac OS 12, like something changed here. You do have a backtrace, though. I get the feeling that it's just something silly here. I think it's just pointer authentication messing things up. Maybe. Actually, I'm not so sure about that. No, it doesn't make it quite sense. Might be that this structure is broken. So I was getting this from reg 0 and 1, which is obviously not correct. No, sorry, this is getting it from the code debugger state. Rex 23, and I think that changed, probably. Almost certainly. Yeah, obviously that's not correct. That's more like it. For panic options, does not work, right? I just broke it. Or not. Yeah, I think so. Second. Going to toilet. Okay. Yep. The 23 is sane. 22 could be it. But I don't think it is. That should be debugger state, panic options current op. You don't sync failure, yeah. 21 could be something. No, this is a string. 24, 25. Oh, that looks good. Looks like it's 25 now. Be nice if there was some nicer way of getting that. It keeps changing with macOS versions. It's not that the panic code changed, it's just the compiler is putting the thing in a different register. It's just dumb. There's probably a better way for me to make that like more robust. Ah, there we go. See, now we have a panic. Kernel data abort at PC blah. Why? Okay. So it's aborting there. FP is not sensible. clearly something went very wrong if we ended up with x21, x29 corrupted. I wonder if it's just that they don't have enough stack. That would very much do it. Like my main stack, I think, have way more, and yeah, probably just that. Do I have any big things in stack? Is there a way of like getting a listing of that? Yeah, that's a good idea, and I think I do that in some stuff. And some of the things have buffers in there. Yeah, I'm pretty sure. There's gonna be a lot of things there, actually, probably. Aha. Oh, debug printf already. Guess I put the buffer in the stack. Yeah. But it has 16K, so that's not that bad. It's gonna be a worse one. HDX proxy already is getting there. Emulate load. Why does emulate load? Oh, probably because it embeds the other thing. Okay, so it's not that bad. But I do want to give it more stack. But yeah, it's not that bad. Expected worse. I think there's a good chance this is gonna work now. No. Oop, or not. SP alignment exception from kernel. That still looks like. And besides, the other kernel threads are always going to be stuck in the spin lock, which is very early in the stack frame. SP got replaced. FP and SP. Okay. Huh. Again, X29. Oh, but it's right after. Look, it's right after a register, so definitely something to do with that. 30 C15 C40. 3015 40 is what? HID4, okay, which we did get before this, I guess. Or not. Oh, I don't hook HID4. But I did. Guess I don't. There's something else happening here. Isn't this the yeah, one. I think this is the like cache flush code or something. Trap HIDI. I do trap them, and yeah, I do pass them. Yeah, so those are passed. Hold on. Am I like not doing that properly? No, it should be. It says that the reset stack. All right, it's relocatable. Uh, oh, DCP ID, sorry. 10FC. Yeah, that's reasonable. Hmm. Yeah, 10C0 and then it's FC plus. Yeah, that's reasonable. I had a similar bug like this before with something with the registers not being handled properly here. What was it? It was what was it last time? It was very similar. It was getting the register, the wrong register. Okay, so that's useful. Oh, hold on. Is it going to be one of those things where this is a P core and something is different on P cores? Is this 8? That doesn't look like it, though. Well, it could be we did more things though. Because the decoded to 3, 1, up 3, 2, 1, 15, 8. Yeah. I don't think I can boot it on 1P core. Zero, 1, 2, 2, 2, yeah. Interesting, it's only using the P cores here. But then when we get to the the E core. So we get to we initialize the P cores, nothing happens, and we start using the P cores and things explode. Yeah. So let's do that. Let's do CPUs equals 4. Nope. Instruction fetch abort. Yeah, well, because that's me. The hell happened here? It returned to like that. Oh, hold on. Hold on, hold on, hold on, hold on, hold on, hold on. Oh no, I'm doing space for that. Hmm. How did we end up? That might be useful actually. EFEB0. Okay, that's not there. But it's not there either. The hell is 42EB EB0? Is that one of the instruction alloc things I do? Or is it just stuck? I think it's just stuck. Yeah. Yeah, it's just stuck. So clearly, like, I'm clobbering stuck somewhere. Huh. Okay, so we're gonna do this the nice way. Let's make sure I'm not screwing up the stacks by going to memory. Yeah, it's gonna add things, but we don't care because it's still gonna be unmapped, so that's fine. SMP. We're gonna have guard pages. Let's see what happens. I really think this is not the problem because like I made it larger and it still didn't work, which is kind of weird. Yeah. Still though, a nice thing to have. So if that's not it, now what is this time? This time it's kernel instruction fetch. Yeah, again, we ended up in the middle of a stack in the kernel PC, which doesn't make any sense. Okay, so let's do 2 CPUs for now. Might make life easier, maybe. Let's see. Yep, I know. I mean, I'm almost there. Oh, is this actually working? No. Kernel data board, okay. FAR at 0, yeah, okay, so. .414, look at that. What is that? Why is there a mini address in the middle of the kernel? 98.060. Oh, that's not even stacks though, at that point. That's what? Logo? No. What? That's a pointer. I should sort this. How do I sort this? Uh, 98, okay. Heap, right before the heap base. Console? Why do we have a pointer to console dot what? The hell did that come from? X18. No, 90, sorry. 980. Heap base. It's right before the heap. Isn't it just padding? No, heap base should be a variable, so it should be before that. There's something else. BHL, right before BHL, okay. Should just do this. I'm dumb. 980 GL2. Oh fuck. That's why. Because that stack, the GL stack, is shared. That's why. Maybe. That's why. Um. And that's why it doesn't happen with Linux, because Linux doesn't use GL. Can I share stacks in some way? I think I can't, because you might need to call into GL for stuff while inside the hypervisor. Yeah. The only thing I could do is if in the exception entry, if we're in GL, try to pick up the stack pointer from not GL. Nah, we have the memory, we don't care. Oh, GL1 stack can just be a single one, because GL1, we obviously know it's for the hypervisor, but GL2 definitely should be like that. And then this should be the same as the secondary start thing. I need the align for that. GL2 stack base. I want there was a thing with assembler here. Types. As we'll do it for GL1 too, just in case. You know, we can. And the XF as do stack. Yeah, so basically take GL2 stack. Not GL stack size. Sorry. I need. Oh, and this needs to be EL1 or EL2, depending. Oh, this only works in EL. Okay, this is kind of broken in EL1 anyway. Do I only do EXF in it if I'm in EL2? I always do it, apparently. And this is kind of broken in... Wait, how does this even... Okay, yeah. It only does this in... Yeah, so it's only use the EL2 one. But then in this case, I need to use EL1 here. something like that. Wow, we're not. Yeah, so GL. Oh, YXF. GXF ASM, and to include that here. Cool. All right, let's go for everything. And oh yeah, I can disable that stupid that debug, which is just going to slow everything down. Did I just kill something? I think I just broke it. Yep, I just broke it. What did I break? See, that I need serial to debug this, or just gonna figure it out. Do I set TPIDR first? I hope I do. Oh no, duh. Help if I do that. Yeah. Nope, still breaking. Let's see, MRS62, TPIDR1. I know we can do that, and then current EL. If it's not equal to 8, which is EL2, skip. Let's move from EL2. Add 1, load GL2 stack. I don't think we need that, but no, because the stack goes down. So it only unmaps the first page, which is the last page in the stack. That's why I have this add 1 to this, right? Because it's actually going to the end of the stack. And this should also be aligned. That's the other issue. Yeah, it's just... That's probably actually the problem. And let's do the same thing here. Okay. Let's see. Okay, now it works. It was the alignment thing. All right. Oh yeah, I need to undo the mapping thing. That's looking good though. Yeah. Cool. Okay. Let me get rid of the stupid that. Actually, you know what? Let's do it nicely and actually put a damn thing here. And actually give it a argument. Yep, I'm gonna make it. Just barely. I got 10 minutes, not 6 minutes. Go on. Will it boot to desktop? Ha! And very fast too, because suddenly we have a ton of CPUs to work with. Oh, that's awesome. The hypervisor just got very fast. Oh, but it still says core 1 only? Or is that just because of something dumb? Oh no, it's scrolling now, I think. I think it's confused due to saving or something. There's a scroll bar. Hold on. Hold on. No, but I think yeah, there's a scroll bar there. There we go. And now can I do that? This is very fast all of a sudden. Hey, it works. And oh, interesting. All of those are like at a fixed frequency somehow. You know, I wonder if the Mac Mini is different or if I broke power management for some other reason. Because it looks like it's not changing frequencies. But the P cores are very fast though. Maybe it's a Mac Mini thing. That wouldn't surprise me. If like somehow when it's plugged in, it doesn't really do terribly. Yeah, see, it's like 100% at this speed, which is almost max, but not quite. And then the E cores are 100%. Where? Oh, that's active resonance, so it's idle. But yeah, see, so like I think CPU scaling isn't working for some reason, which explains why I wasn't seeing the P state changes. But yes, it works. Multi-core, yay! And like all of this stuff now makes sense. So cool. Awesome. So yeah, I'll have to figure out why the CPU frequency stuff doesn't work later, but I'm sure I can figure that out. Maybe it's just something I messed up in the ADT. Or maybe it's just some, like, it doesn't like some of my emulation of some things. But we'll see. Awesome. Also, I have a lot of junk here, as you can see in the history. Let me clear scroll back, and actually, let me... Nah, that's fine. I'll have to look into why the core stuff isn't working. There's probably something in the logs. But okay, cool. Then that's all for today. That was a nice yak shave. I'm very happy with how fast this hypervisor has something. Oh, hold on, let's just reboot. Let's just watch that once again. Let's just see how fast that thing boots now, because it's kind of crazy. Also, I wonder if like this debug stuff has to do with the problem. But anyway, yeah, let's just watch it boot one more time. That's like bare metal level speed. I think that's as fast as... Okay, you saw how long that took, right? This is bare metal now. Hold on, let me get there. Okay. It's like the same. It's like basically the same. And I want to know if this happens in bare metal too. No, okay, so it does power down the core. So clearly, power management is broken for some reason. It might be that it just disables itself as if it's in a guest mode or something. I'll have to figure something out. But yeah, no, okay, cool. Yep, awesome. So, yep, see you later. I'm going to watch Alyssa's talk, and you should too. It's about reverse engineering the GPU in this thing. So, cheers.